So this one is a second part of our gradient, second session on the gradient, we'll say. Three examples we already finished on gradient. There are three important formulas or names for the gradient that we already seen in the last session. Whenever the question says find the gradient of the given function phi, yes, we are calculating that del phi vector. This del phi vector is known as a gradient of a phi. It can be denoted as a grad phi. Okay. Another name for del phi is known as a directional derivative. So whenever the question comes, find the directional derivative of the function phi. Yes, we are calculating del phi only. Okay. And the third thing, if we are interested to get a normal vector to the surface, then also we are calculating del phi only. So normal vector to the surface, normal vector to the surface at that point, at a particular point. So these three things, whenever the question comes, find the gradient. Just a minute. Okay, just 1 minute. So if a question comes, find the gradient, find the gradient, find the directional derivative, find the normal vector to the surface. Yes, the same thing that we have to find it here. That is the del phi here. Okay, let me continue with examples now. So the question that we have here, find the directional derivative. Now the keyword that which indicates we have to find out del phi is a directional derivative. So this directional derivative indicates we have to calculate this del phi. Okay. Now the formula for del phi, the formula for a del phi is, that is a directional derivative, is dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. So let I ask 144. Okay, 144 will. Okay, so this is the little problem that every time I have to make unmute. Okay, 144, you can unmute yourself and tell me the answer. 144, not there. 162.
Yes, sir.
Tell me.
Sir, del phi by dx equals to
Hmm.
0 I cap.
How 0? We are differentiating phi partially with
Yes,
respect to
sorry,
x.
sir.
Treat y
Sorry,
as
sir.
the.
Sorry, sir. 2x y square z square I cap.
Yes.
Then x square 2y z square j cap plus x square y square 2z k cap.
Yes, correct. So that about partial differentiation. This is partial differentiation, and we say this is
Yes.
the directional derivative at any point xyz, any point xyz. Now,
Yes.
okay, mute yourself. Then we want that next step is obviously we should find out at a particular point. Therefore, at a point 1, 1, minus 1. So this is the step number 2. Step 1, we calculate general directional derivative. Step 2, we are calculating a particular directional derivative at a particular point at 1, 1, minus 1. So 141, tell me the answer. Arpit. 145, Ayush.
Yes, sir.
Tell me, what is the del phi here?
2 I cap
Okay, 2I cap
plus 2J cap
plus 2J cap
minus 2K cap.
minus 2K cap, correct. So here Z is only negative, other there was a square, so it is obviously 2I cap plus 2J cap minus 2K cap is a correct answer. What should be the next step now to get the directional derivative at a particular direction? What we should calculate?
So the projection.
Projection, but projection along which direction?
The tangent
So
will
how to
find
get
the
a tangent?
tangent
So we have to find dx by dt, dy
by
by
du
dt,
Okay,
and dz
so
by dt.
before that, what we should write before differentiation? We should write the equation of a curve, that is r bar, which is xi cap plus
plus
yj cap
j
plus
cap.
zk cap. So this is the equation of a curve. First we should write the equation of curve and then we can find out the tangent equation. So the values of xyz we are given, which is e raised to t I cap plus 2 sine t plus 1 j cap, and the value of z is t minus cos t k cap. So all these things given, these values of components of x, y, z. Therefore, tangent, which is a t bar, is a dr bar by dt. And now, yes, we can differentiate it and we get that particular first general tangent. What's the differentiation here? It is obviously e raised to t, derivative is e raised to t itself, plus 2 cos t j cap plus 1 derivative of now minus cos t become a plus sin t, 1 plus sin t k cap. So this is the general tangent vector and we want a tangent vector at a particular point. And what is that point?
T is equal to 0.
T is 0. So put a t equal to 0 and tell me
Easy.
t bar. Therefore at t equal to 0, t bar is e raised to 0, 1.
1.
What about cos 0?
1
Yes, so 2j cap.
1, sir.
What about sin
plus K
0?
cap.
Yes, plus k cap. So that about the second part of the question. The first part, we calculate a directional derivative at a point 1, 1, minus 1. This is the vector which gives us a directional derivative here. Next, we calculated a tangent vector to the curve at t equal to 0. And now the last step, we want this del
Del
phi
phi.
vector along a t bar. So we are going
Yes,
to
sir.
take a projection. The
Yes,
projection of
sir.
a del phi along t bar. And what should be the answer? That is a
Del phi dot
Projection
T
phi
upon T bar.
into
del phi dot t
into
bar upon t,
by
upon magnitude
upon
of t bar.
t
Yeah, correct.
magnitude.
Yes. So let me finish the last part then. So I'll erase a small part from here. Therefore, directional derivative of a phi along t bar is equal to del phi dot t bar upon magnitude of that t bar vector. And let me take a dot product now. We have this is a del phi vector dot this vector. So like a1 b1. So 2 into 1 is a 2. Then again 2 into 2 is, that is 4.
Minus
Lastly
2.
minus 2 into 1 is a minus 2 divided by the magnitude of a t vector, that is 1 plus 4 plus 1. 1 plus 4
6.
plus 1. So what should be the answer?
So 4 by root
4
6.
by root 6.
4 by root 6, and that is
4
the
by
answer. This is the answer that you should have. Any doubt here?
No, sir.
No doubt. Okay. So if you complete, tell me. We'll move to the next question. Okay, one is on the chat. Let I check. Okay, done. Very good. 157 said. So I will clear this screen then. Okay. So question 5. Question number 5 is on the screen now. Our aim is to find the constant a and b so that this surface 1 and another surface 2 both are orthogonal at this point 1 minus 1 2. 1 minus 1 2. Yes, anyone? What should be the way to get these values of the constant a and b? Yes, 146. Yeah, 146, 142. Are yes.
Yes, constant surface. So we'll again first we'll take out the del phi,
Okay.
and after that, since it's orthogonal, right? The surface of point.
Okay. See here, the important things you should focus. We are given the two surface equation. Say the surface 1. I will draw a rough diagram here. Suppose this is the surface 1, which is a phi 1. Okay, I will give that name here, phi 1. Let phi 1 equal to ax square minus byz. Remember, function of xy equal to constant or function of xyz equal to constant. That is the way we write a surface equation. So this term we should take on the LHS. Minus a plus 2 of x equal to 0. So this is a phi 1. Okay. Now let me say phi 2. Phi 2 is a 4x square y plus z cube, and now RHS is a constant, so no need to take on the left side, or if you take it on LHS, that also doesn't matter there. So let I say this this is a front view of the surface phi 1. Actually this is the surface, so, or you can say cross section of the surface phi 1, and let I say there is another here, say this is the surface phi 2. Surface phi 2. Now we are given, and let me say this point is on both the surface. So 1 1 minus 2, 1 1 minus 2 is this point, and we are given these two surfaces are orthogonal. Now when these
Sir,
surfaces
I have a
are
small doubt. Can
pardon?
I have a small doubt here. If two surfaces are orthogonal, so would their tangents be also orthogonal?
That's one, correct. So that is
Okay,
only
okay.
the property we are going to use it. It is similar to the curve only. Right now what we done, so when two curves are orthogonal to each other, their tangents are orthogonal. So right now we taken a just cross section of that surfaces. So cross section just like look like a curve here, and these surfaces are orthogonal. That times the tangent to the curve, tangent to the surfaces at that points are also orthogonal. But instead of tangent, we are going to use the normals, because we already know the normal is perpendicular to the tangent. Normal is perpendicular to tangent. If tangents are perpendicular, the normals are also perpendicular. So what we are going to do it, so let me say del phi 1. This is a del phi 2 actually. This is the gradient of surface phi 2, so that it is perpendicular to the phi 2 at that point. Similarly, we can have del phi 1 perpendicular to surface phi 1. As phi 1 and phi 2 are orthogonal there, del phi 1 and del phi 2 should be orthogonal. They should be a perpendicular. So this is the property we are going to use to get the equation between A and B. But you'll observe that we have to find the values of a two constant. So we should have two equations for a and b. First equation is obviously we get by del phi1 dot del phi2 equal to 0. What about the other equation? How to get one more equation between constant a and b? Yes, anyone?
Sir, the equation of one will be satisfied by the other, na?
Very good. So that's the correct. So as we know, this point is on the both the surfaces. This point will satisfy both the equation. So if you replace x by 1, y by 1 and z by minus 2, you will get phi 2 is equal to 4. And that is obviously because that 1 1 minus 2 is on that point is on the both the surface. Same thing will happen if you replace this 1 1 minus 2. This sum should come as a 0 and automatically we get one equation for a and b. So we can start like this here as 1 1 minus 2 is point of both surfaces. This implies phi 1 equal to, so we are replacing x by 1, so that is a. B is also 1. No, sorry, not b. Y is 1 and z is a minus 2, so it is coming plus 2b.
Excuse me, sir.
Yes.
So the point is 1 minus 1 2 or 1 1 minus 2?
Okay, my mistake. Yeah, correct. It is a 1 minus 1 2 is the correct point. So if you replace a wrong point, it may not satisfy there. Good. Okay, thank you. So it is 1 minus 1 2 is the correct point there. So because of that, let we see what happens here. So we are replacing x by 1, so that is a. Okay, b is a, sorry, y is a minus 1 and so it is plus 2b, not any problem. But here minus of a plus 2 is a 0. So obviously here this a gets cancelled and we left with this 2b is equal to 2, because 2b minus 2 is a 0. 2b minus 2 is a 0, and this gives us b is equal to 1. So one of the constant we get directly. We got the value of the constant b as a 1, here by putting that point on surface phi 1. Okay. Now to get another value of the constant, or the value of the constant a, we use this condition del phi 1 and del phi 2 are orthogonal, therefore their dot product should be 0. So first let me compute del phi 1 and del phi 2. We will start here as a, now del phi 1 equal to yes, anyone tell me what is a del phi 1 vector general?
2ax
Very good. 2ax
minus a plus 2.
minus a plus 2, or minus a minus 2, I will write it. Okay,
Yes.
I will
I
erase
kept
the brackets also. Okay, no need of a bracket. Okay, the bracket I will keep. Yes, this is I cap, correct. So this is a dou pi by dou x, dou pi 1 by dou x, sorry. Yes, now second plus
minus bz
minus bz, correct,
j cap
correct, and is it
minus by k cap.
good? Okay, del phi 2. Yes.
8x
8x1
8xy
179. Yes.
plus 4x square
Okay,
plus 3z square
correct. So
k cap.
the meaning of these two equations are, these are the gradient for the surface phi 1 and phi 2 at any point xyz, but we want these gradients at a particular point which is 1 minus 1 2. So we'll say at 1 minus 1 2. Now del phi 1 equal to, replace If you replace x by 1, y by -1 and z by 2, so tell me what is the del phi 1?
So can we replace B also?
Pardon? Yes, you can replace b
Can
also. You can replace the value of b also there. Also b equal to 1, so that you can get directly the value of a. Okay, so or we'll say like this. Okay, that way also we can proceed. So we'll say at 1 minus 1 2 and b is
Sir,
equal to 1,
A minus 2 I cap.
del phi 1 is,
A
yes,
minus 2 I cap.
a minus 2
Yes, sir.
I
I cap.
cap.
Minus 2 J cap.
How minus 2 j cap? Value of b is 1 na? Okay, sorry,
Yes, sir.
correct,
B
correct, correct. My mistake. Yeah, minus 2j cap, correct, good.
K cap
And
plus K cap.
plus k cap. Okay, so this is the del phi 1 vector. I will give this as equation 1. Now one more equation we should write. I will write it on the top here now, this side. Del phi 2 equal to, with the same things, 1 minus 1 2 and b is 1. Yes, here is del phi 2. Replace x by 1, y by -1. So it is minus 8 I cap
Minus 8 I cap plus 4 J cap
plus 4j cap, okay,
plus 12 K cap.
plus
12 K cap. 12 K
12k
cap.
cap, correct. Now we have this equation 1 and 2, which are the normal surfaces, normal vectors to that, both the surfaces at that point, as they are orthogonal now. So we should say, but del phi 1 is orthogonal to del phi 2. Okay. Del phi 1 is orthogonal to del phi 2. Therefore, therefore, del phi 1 dot del phi 2 should be 0. And this gives us, now let me take a1 b1, so minus 8 times a minus 2, 4 times minus 2, that is minus 8 only, 4 into minus 2, and lastly plus 12 is should be 0. So it is just like a1 b1 plus a2 b2 plus a3 b3. Solid now. This is a minus 8a plus 16 minus 8 plus 12. Is it a 20? Plus 16.
So the answer is 20 by 8 or 5 by 2.
Okay, correct. And a should be 5 by 2. Okay, this is the, okay, just a minute. Okay, so there is the final answer there. A is a 5 by 2. Any doubt there? So this question was asked in 2018. 7 marks there. Now these questions can come for 5 marks according to new pattern. Actually, old question papers are of 100 marks, and that time these questions are coming for 7 marks. But now the same question is coming for 5 marks because the weightage is reduced to the question paper is coming of 70 marks now instead of 100. Any doubt here?
No, sir.
No. So can I clear the screen and move to the next question? Okay.
Yes, sir.
Yes, thank you. Okay, so that about the different, so these first 5 example, if you understood this first 5 example, remember now, all remaining questions will be the repetition of that. So already we discussed which type of the questions will come in the exam. Type 1, find a normal vector to the surface. That is the first type. Second type, find the gradient of the function phi. So simply del phi you have to calculate. Type 3, we have to calculate directional derivative along some direction. So that is the type 3. Type 4, we are given two surfaces are orthogonal and find the value of a constant. So that about the 3-4 types are there only. Now all the remaining questions will be the repetition of that only. So let me do 2-3 examples of the exercise, and remaining you can do it like the exercise then, that as a self-study. So yes, anyone tell me where we should start here. The question is find unit.
So we'll find del phi.
Yes, first we should give the notation. Let phi equal to xy cube z square equal to 4, and we want a unit normal vector to the surface. So first we'll find out
Del phi by magnitude of del phi.
Yes, what is a del phi here?
Y
Y cube
Y
z
cube
square
z
I.
So x squared I see.
x
plus x3 y square z square
Plus,
2xy cube z.
yeah, correct. So this is the general normal vector. This is a normal vector at any point x, y, z. We should calculate at this point. So at 1, -1, 2, this del phi vector will become. So this is the particular normal vector at that point. Yes, anyone? Yes, what is this vector?
-4 I cap
minus 4i.
Okay,
plus 3j cap,
yeah.
then
And
8k cap.
So
Sorry,
12K cap.
16.
how much?
16.
12K
16k.
cap.
Is it plus?
Yes,
Is it plus?
It should be 12j cap,
12K cap.
3j cap.
Okay, 2x is there, 2y cube minus, and
No, sir, I'm talking about the j part. It would be 12j cap.
12j cap. Is it plus? Yeah.
Yes, sir.
And I think this is also not correct.
It is -4K cap.
Correct. So this is the vector that we got, and this vector is known as a normal vector to the surface at a point 1, 1, -2. But we want unit normal vector. So the last step, therefore unit normal vector is equal to, yes, obviously we should divide by its own magnitude. And you should check whether this answer you will get. One thing is there, you can take 4 as a common and it gets cancelled. You'll observe the answer you will get as a -I
4√11.
plus 3j minus k divided by square root of 11. Why this happened? Because when you divide by magnitude, yeah, you can take this 4 as a common, and when you so that is 4 upon 4 gets cancelled only. Or you can use a calculator and cross check. This will happen. The 4 is coming common from numerator, as well as it will come from the square root. Then in square root you get 16 into 11. 16 into 11, that's 16 comes outside the square root, it becomes 4. The 4 will get cancelled and you get a required answer. Any doubt here?